This is IAT814 Visual Analytics.
Lecture 2.3, and we're going to speak briefly in this segment about simple data models. So, as we've seen before in this repeated diagram, models are what you're doing either explicitly or implicitly when you're transforming raw information through a data transformation into a data set. And we're just going to show, again, simple examples using tables. So basically, the way things work is the raw data form tends to lead to some kind of conceptual model, which tends therefore to lead to a type that you can then use inside your visualization. And the act of modeling is the creation of this transformation chain from the raw data, whatever it is, numbers, strings, etc., to a conceptual type, say temperature or something, to a type that you can use. So here's the little example, just this sketch of an example. Let's say you've got a raw data that has a bunch of floating point values, and they're, as I just said here, floating point, and you know somehow or other that those are temperatures in degrees Celsius. You can then transform those temperatures into one of what I'm showing here, just three possible types. One type is nominal, which is kind of silly, but is burned versus not burned. Let's say you're talking about the kindling point of paper or something. Everything below some limit is not burned, and above that limit, above 451 degrees Fahrenheit, whatever that is in Celsius, that is burned. Another data type could be ordinal, where you have cold, warm, and hot, where hot is greater than warm and warm is greater than cold. But these are broad categories, and they're perhaps about the subjective impression of what the temperature is like outside, something like that. The third option that is shown here is just simply taking the temperature values as genuine Celsius degrees measurement and plotting them, displaying them exactly as the temperature values are stored in the data set, in the raw data file. Another way of thinking about creating models is to use the relational or tabular data model. And what we're doing here is using the language of database systems, particularly relational database systems, to talk about data tables and the way in which the elements of the tables work together. So what the primary concept of a relational database is the relation, and that is we have a collection of data in a table, a rectangular table, just of the kinds we've shown so far, and that table represents a relation amongst the variables for each individual item in the data set. Each row in the table, or tuple in the table, represents a single record, or data case. And each record is a fixed length tuple. And a tuple in this case is a series of numbers or strings or whatever it is with information about what each of those things is. So each column or attribute in the table represents a single variable, and each attribute or column has a name and a data type associated with it, string, ordinal, nominal, whatever it may be. The table's schema is the set of names and data types. And so here's where the database terminology comes to the fore. It's a set of names and data types. And a database is a collection of data tables, which, again, a table is a relation amongst different variables. Okay? So you can create a model of a data collection, which might be very, very complex, that is built up of a collection of tables, which in each table of which is a collection of variables with these descriptions as to how those variables work. So here's another table. This is the classic iris data set. And what's being shown here are a number of measurements taken by a guy named Fisher in 1936 of irises, that is to say flowers, species of irises in the Gaspé Peninsula in the 1930s. And what's being measured here, what's being shown here, is a table where this variable is the ID, a case number, species number, which is 1 through 3, so that's treated nominally, the species name, and 1 is Setosa, 2 is Virginica, 3 is Virginica, 2 is versicolor, and what's being measured here are the petal width and length and sepal width and length. So the database is the data collection is mixed together because sepal and petal are treated as if they're separate data cases here. So the way in which this can be treated is that the width and length can be treated as quantitative data. The ID and the case number, although they look like numbers, they can be treated as ordinal data. And the species number and species name, those can be treated as well as sort of the organ name as well, can be treated as nominal data. So that's a very brief indicator of how to take raw information that you might find in tables and transform that into a data set, a model that can be used for further visualization steps. So this is the end of lecture 2.3, Simple Data Models.